Hi, in this video I'll be demonstrating how to use your alarm system to monitor whether your main supply is on or off. Here I have an alarm system. This is the alarm panel. On the front here, these are the different zones, and what I want to do is I want to determine if the mains has gone off. Now you might be wondering whether the alarm system already has that built in, so why would someone need to measure the mains in order to determine if it's on or off if the alarm gives that measurement anyway? Yes, it's true that certain alarm systems will send a warning to you or a notice to you that the alarm panel has lost the main supply. But what happens if your alarm panel is on a three-phase supply? What that means is we have live 1, live 2, live 3. Now, because the alarm only monitors a single phase, what do we do with the other two phases? So that means that if the one phase goes off and it's for the alarm, then fine, I was lucky. The alarm will tell me the phase has gone off. But what happens if phase 2 or phase 3 went off, but those weren't connected to the alarm? So in certain circumstances, we want to measure where the other phases of the main supply are on or off. Now, this is particularly useful if your alarm system is connected via a UPS. So say, for example, your mains feeds a UPS. The UPS provides maybe 6 hours of backup time, and this is powering your alarm. That means that if the power goes offline, we still will not know because the UPS will feed the alarm for 6 hours in this case, and the user will only be notified of a mains failure after 6 hours has expired. So that's not very useful because the user needs to be notified of a mains failure immediately once the mains has failed. And then in the other situation, as I said, if it's a three-phase supply, you'll have live 1, live 2, live 3, and only one of these will be connected to the alarm because I'm not aware of any alarm system that needs 3 phases in order to operate. So if phase 1 goes down, fine, the user will be notified. But if phase 1 stays on, but only phase 2 or phase 3 goes offline, the user will not know because the alarm is not monitoring phase 2 and phase 3. So in this video, I'm going to demonstrate how I am going to monitor the other 2 phases of my main supply so that if any of those 2 phases go offline, then I will be notified by 2 zones on my alarm system. Now, you might also be wondering why one phase would go offline and not all 3 at the same time. Well, this is quite common in domestic applications where there's an overcurrent on one phase. Maybe one of the users has plugged in too many appliances and overloaded the phase and the phase cuts off. Or maybe there's a problem on the supply side and your utility has only given you the line 1, but line 2 or line 3 is offline and you would not know if you were not at your home or business. And this is why I'm now using my alarm system to notify me or my client that the other 2 phases have gone offline. And I'll quickly show you an outdoor installation of why this happens quite a lot in South Africa, because a lot of the installations have mixed circuit breakers. What that means is instead of having the correct current rating, they have now mixed and matched them because of a variety of reasons such as theft, lack of stock. And I'll now go and show you an outdoor box with that exact problem where the circuit breakers for the 3 lines are actually unmatched. And for this particular client, this person often has only one phase going down, and I'm going to make it that this user will always know if any of the 3 phases goes offline. Right, now I'm on the street and here is a little box and I'll show you what I'm talking about by mixed circuit breakers. Right, the circuit breaker on the far left is a 60 amp while the other 2 are an 80 amp, and also the type of circuit breaker, the orange ones are also different to the white one. And just judging by the look of this outdoor box, you can see that there have been faults here. Now, in order to do this, you will need some electrical components, and there is a severe shock hazard because we are going to be using the mains voltage. Now, this is the circuit diagram of how I'm going to do this. The mains comes in over here. So this would be my first phase. So I've called it phase 1, and it comes into the circuit breaker. And in this case, this could be an earth leakage. So over here, the live would come in here, the neutral will come into here, and then this is an earth leakage with overcurrent. If I measure the voltage here or connect a relay to this output, I will always know if the mains is on or not, or also if the earth leakage has tripped or not. This is also providing me an update on whether the earth leakage has tripped. Now, in many European countries, they're using the DIN rail. So yours would look something like this. Your live will come in there or there, and your neutral will come in on the opposite wire. And on the output, I can now measure whether there is a voltage signal there or not. Now, you might want to do this after a smaller circuit breaker. For example, this is a 10 amp circuit breaker. And the reason why I say that is because the wire that we use after a circuit breaker has to match the circuit breaker's current. For example, if I am going to be using this, I actually have to use a 63 amp cable, which is now a massive cable. While if I do this with a 10 amp circuit breaker, I can use a much smaller wire such as this. Remember that we have to match the wire to the circuit breaker. Right, so there's the circuit breaker. If you're more comfortable, you can use a lower amp circuit breaker, but straight from the circuit breaker, I need to go to a fuse. So there, from the live wire of the output from the circuit breaker, I go to a fuse. I'm just going to use a 1 amp fast blow. Then it goes onto the coil side of my relay. So over here, I have a relay. This is a 220, 240 volt relay. If your power supply is a 110 volt, you would then be using 110, 120 volt relay. Then the output from the coil side of the relay goes back to my supply via the neutral. So this is an AC circuit. So on this side, I'm actually using AC voltage. Now the relay will be always on when the supply is on. So if the supply is on, the relay will actually be closed. Now on the output side of the relay where I have my contacts, it will be closed, and this will be wired directly to my alarm system. My alarm uses a 3K3 inline resistor. So that is the resistor which maintains a constant volt drop for my alarm system. If the power goes off, the relay opens. And if it opens, the alarm notices that by the increase in voltage, and the alarm will send me an output telling me that the power, the mains, has gone off. And the alarm will send me a warning telling me that this mains has gone off, this phase. Now, you might be wondering, isn't it dangerous to connect the line voltage to the alarm? But I'm not connecting the line voltage to the alarm. I'm connecting the line voltage to a relay. The relay has a set of contacts on the other side which is connected to the alarm. So at no point in time am I putting my alarm under any risk by connecting AC mains on these zones. Absolutely not. Every relay is different. So say for example this relay over here, this is a DC relay, follows the same principle of operation, but as you may see, the wiring of the pins is different, and also the number of terminals at the bottom is different. Now I don't need so many poles here. It's just this is the relay that they had in stock, so I'm using this one. I also have another AC relay. It looks a bit different, but it does the same thing, but as you can see has even more poles. In this case, I'm going to be using a double pole, double throw relay. And if you'd like to see videos on how to use relays, how to understand the poles, how to test them, please check out my playlist on relays. So in this case, my alarm will now be able to measure whether the mains for this phase is on or off. Let's call that phase 1. And then I will do the exact same thing again for phase 2. And for phase 3, I'm not worried because that phase is directly powering the alarm. If I needed to measure 3 phases, I would then make 3 of these circuits. Unfortunately, you may not use the live from this phase and connect it to the live on that phase because this phase voltage and this phase voltage are 120 degrees out of phase from each other. So that may be V1, this is V2, V3. While they may be the same voltage, they are actually 120 degrees out of phase from each other, and therefore if you touch this line onto that line, you'll actually have a short circuit. So therefore I cannot do that. I have to keep these parts isolated, completely isolated, and that is why I will be using 2 relays and have everything in duplicate. Right, so let's just recap again. I'm going to go from the output of the circuit breaker straight into a fuse. There's a fuse holder. You might also want to use an inline fuse holder like this or like that, but just make sure they are rated for the line voltage, such as this one is rated 220, 230 volts, while these ones are often used in lower voltage applications, car applications. But just make sure you check, because some of these are actually designed for DC applications. Right, so you'll need a fuse, and then from the fuse it will go into the relay. I'll have to solder it onto the relay connection, so you will need a soldering iron. And then from the output of the coil side, I go to the neutral, which means that I will need a black wire, because the neutral in South Africa is black, but in your country it might be a different color. In this case, because we are wiring into a distribution board, we have to comply with the various codes that are applicable for distribution board wiring. Now, on the output of the relay, there we go. All I need to do is solder my 3K3 resistor, and my other wire goes to the alarm with the output from the 3K3 resistor, and I'll wire it up just like I would any other zone. So if I was going to wire up a passive infrared sensor, for example, there are my alarm wires for the particular zone. There's the usually normally closed, while now the normally closed would just be wired directly to a relay via a resistor. Right, something that's extremely important when you are connecting up this type of circuit and you're measuring live and neutral, make sure that the neutral wire of your relay is connected to the correct neutral bus bar. Now, I highly suggest that if you are wiring yours, wire it after a low amperage circuit breaker, because I have explained about the thinner wire being a restriction. So because I use a thinner wire, I need to wire after a smaller circuit breaker. But if you did wire yours after the residual circuit breaker or the earth leakage, whatever you want to call it, if you wired it after the earth leakage, then you have to wire the neutral also after the earth leakage. Now, a last thing you might want to consider is, because we are using line voltage, we might want to put this in a container of sorts. So I'm going to have my 2 relays in a little box like this. If you've got VeraBoard, you can also make a little circuit for this application. I'm going to do it like this. I'm going to wire it directly onto here, and then I will close this so that there's no shock hazard. Remember that the one side of that relay is sitting with 240 volts, major shock hazard, so you can get an electric shock and your life may be at risk. Okay, so now I'm going to start with the wiring. If you want to see how to wire a distribution board and some of the rules, please check out my playlist on electrical tutorials. Okay, only commit yourself to this job if you are comfortable working with mains supply. Right, I am going to now wire this up, and then I'll show it to you once it has all been wired. Right, over here I have a 3-phase distribution board. There's phase 1, 2, and 3. Here is the main switch to disconnect all 3 phases. Now, as I said, in order to monitor phase 1 and 2, I've now installed these 2 relays. There you can see the relays. These relays are mounted on the side here. I will still cover it. I've left it open so that I can demonstrate how I did the connections. I've wired this first relay. So this is phase 1. This is L2, so this is phase 2, and I'm not doing phase 3 because that's already connected to the alarm. The alarm will automatically send me a message if the power is turned off to the alarm panel. So in this situation, I now have additional monitoring of this line, or this phase, and this phase. Right, over here I have my 2 relays, and notice the live and the neutral, and the live and the neutral wired to the coil side of each relay. Then on the contact side of the relay, there's my terminating resistor, the 3K3 plus the other wire, and the 3K3 plus the other wire. These are going to the alarm. It's very important to run your alarm wires away from your AC wires. Right, so this is fed directly into the DB board, while the alarm wire runs on the wall and into the roof. So that's what it looks like from the side, and I'll quickly show you the alarm wire. There's the alarm wire running into the roof, fed all the way to the alarm panel. I've wired it to 2 open zones. Right, I'll just demonstrate it before I close it. So this is phase 1. So if I drop the earth leakage, notice the relay contact will open. And if I drop phase 2, notice that phase 2's relay contact will also open. If I re-energize phase 2, there you can see the relay has closed. And if I re-energize phase 1, you'll see there's the relay now closed. Right, now I've closed the container. There's the DB board is now closed. I'll quickly show you the status monitoring on the alarm LCD. And there it's actually flashing phase 2 off. So I could now set that as a warning zone, and then it can actually activate and send me a message on a phone. Right, so in this case it is zone 56, and earlier today I was setting it off. There it says, you can see there's an activation and it's zone 56. So that is now telling me that I have a power outage on that phase. Thanks for watching and cheers.